What if I told you that the enterprise software you rely on right now, the CRM you log into every morning, the accounting tools, all the design platforms,
Basically everything running a modern business.
right, literally all of it. What if I told you that it's built on a business model that is, well, it's about to become completely obsolete?
It's a pretty wild thought, honestly.
Yeah, I mean, today, your company pays for a software license. You buy a seat for a human worker to sit in front of a screen and do the actual labor, right?
Exactly. The human does the work, the software is just the tool.
But what happens tomorrow when the software, no longer needs a human operator?
That is the million-dollar question.
Right. What happens when you stop paying a tech vendor for a digital workbench and you start paying an artificial intelligence for its actual digital labor?
It completely flips the script on how we value technology. Totally. So if you are, say, prepping for a major tech strategy meeting, or you're just trying to wrap your head around where AI is actually going next, beyond all the breathless headlines and the endless hype, well, this deep dive is tailored exactly for you.
We are getting into some incredibly comprehensive architectural materials today.
We really are. The main source today is this deep in the weeds strategy document, and it's titled Architecting AI Agents, from Specialized NLP Pipelines to the Strategic Multi-Agent Ecosystem.
It is a mouthful of a title, but the contents are just gold.
Yeah, so our mission today is to cut right through all that heavy jargon. We want to deconstruct what is actually happening under the hood as we transition away from basic AI chatbots.
Right, the simple ones you use to just, write a quick email or summarize an article.
Exactly, moving from those to complex autonomous multi-agent systems. And we really want to map out what this evolution means for the future of software, for developers, and for the businesses buying it all. Because, this isn't just about cool new tech. We are looking at a fundamental shift in how we build, how we test, and even how we buy software.
It's a total rewiring.
It really is. The mechanics of the digital enterprise are basically being ripped down to the studs.
Well, let's start right at the foundation of that rebuild,
Yeah.
because the source material demands like a total mental reset before we even touch on the specific tech tools.
Oh, absolutely. You have to understand the paradigm shift first.
Right, and there's this core concept in the deck outlining a hard dividing line between two totally distinct eras of computing. On one side, we have traditional software and RPA.
Which stands for robotic process automation.
Yep. And on the other side, we have AI agentic workflows. And I mean, the way these two paradigms operate, they couldn't be more different.
No, they really couldn't. To grasp where we're going, you have to look critically at where we've spent, the last 50 years.
The traditional stuff.
Exactly. Traditional software development is built entirely on the premise of repetitive, rule-based tasks. The defining characteristic is linear execution.
Linear meaning, like a strict sequence.
Right. Step 1 to step 2 to step 3. You have structured inputs, and they move logically down the line to a final output.
It feels like the ultimate digital assembly line.
That's exactly what it is.
Mm.
And a massive prerequisite for that assembly line is what the materials call structured data.
Meaning the software only works if you feed it information in the exact format it expects, right?
Yes. It needs a perfectly formatted spreadsheet or a highly specific database entry. If you give it messy data, the assembly line jams.
Because the rules are absolute.
Exactly. And because the inputs are rigidly structured and the rules are absolute, it yields deterministic outputs.
Deterministic output. So meaning if you put X into the system, you get Y out every single time.
Without fail, determinism has been the holy grail of software engineering since day one. Predictability is safety.
Right.
Now, look at the other side of the paradigm, the AI agentic workflows. That linear progression completely shatters.
We aren't doing step 1, step 2 anymore.
Not at all. We are no longer dealing with highly structured, predictable inputs. The inputs here are explicitly defined as unstructured and varying.
Messy data.
Really messy data. It might be a poorly worded email from a client or, a scrambled PDF invoice, or just a really vague text prompt from a user.
So instead of feeding that mess into a rigid step-by-step pipeline, all those varying inputs flow into this central concept the deck calls the AI agent core.
Right. And the mandate of that core is entirely different. It isn't instructed to just execute commands blindly. It's instructed to learn and adapt.
I am trying to picture what that actually looks like in practice, though. Because if the inputs are messy, the path to the solution obviously can't be a straight line.
It isn't a straight line. What happens in an agentic workflow is that the agent core maps out a predicted path toward a goal, but then, inevitably, it hits an obstacle.
It hits uncertainty.
Exactly. Now, in traditional deterministic software, an unexpected obstacle breaks the entire system.
Right, the program throws a fatal error, it crashes.
And it sits there completely frozen until a human developer comes in, finds the bug, writes a new rule, and pushes a patch.
But the AI agent doesn't crash.
No. When the agent core hits that uncertainty, it makes an adaptive decision. It evaluates its surroundings. It can explore an entirely different option or refine its current path to work around the roadblock.
It's actively problem-solving in real time.
Yes. And because it's dynamically shifting its approach based on the environment, you don't get that guaranteed single deterministic output anymore. You get probabilistic outcomes.
Probabilistic,
Hmm?
meaning you might get outcome A today or outcome B tomorrow, depending on the route the agent had to take to solve the problem.
Exactly. This requires a total mental reset for developers. You are no longer writing a micromanaged script for a blind machine. You are establishing a goal, setting boundaries, and then granting the machine the cognitive flexibility to figure out the logistics of getting there.
The analogy that keeps coming to my mind as we discuss this is transportation.
Oh, that's a good way to look at it.
Yeah, if you think about traditional deterministic software, it's exactly like a freight train on a fixed track.
Highly efficient, highly predictable.
Exactly. You know, down to the minute when it will arrive at the station. It follows the rails perfectly.
Yeah.
But its entire existence is so fragile because it relies on the environment being flawlessly prepared for it.
Right. If there's a penny on the track or a fallen tree branch, the whole thing
It
derails.
just stops. It cannot adapt. It waits for a human to clear the track.
They are brilliant but brittle systems.
So, if traditional software is a train on a track, these AI agents are like an off-road autonomous rover, like a Mars rover.
Right, there are no tracks on Mars.
Exactly. You give the rover a general objective travel to that crater and collect a rocks sample, but you don't map every inch of the route. The rover has sensors, it starts driving, and if it encounters a massive, unexpected boulder, it doesn't crash into it and wait for mission control on Earth to rewrite its steering code.
It stops, assesses the boulder, and calculates a new route.
Autonomously. It might arrive at the crater from a slightly different angle than mission control predicted. That's your probabilistic outcome. But it accomplishes the mission without human intervention.
I love that analogy. And tying this back to the broader implications for business, the materials summarize this transition with one defining quote. It says, "We are moving from a world of predictable software to a world of probabilistic outcomes."
That feels like a seismic shock to enterprise IT.
It is. The entire corporate world is built on demanding exact predictability from its tech. Transitioning to managing probabilities rather than absolute certainties will force every department, legal, HR, engineering, to totally rethink their relationship with software.
Okay, so that gives us the philosophical groundwork. We are moving from the train to the Mars rover. But, philosophy doesn't write code.
Very true.
How are developers actually building this off-road rover right now? To understand that, we need to peek under the hood at the specialized tools making this autonomy possible. And the architecture documents start by highlighting an NLP specialist known as Haystack.
Haystack is a phenomenal lens for this evolution. Before we talk about agents acting out in the real world, we have to understand how they process information and understand context.
Which is natural language processing, or NLP.
Exactly. And the origin story of Haystack is quite telling. It was developed back in 2018 by an organization called DeepSet.
2018, in AI time, that might as well be the Jurassic period.
It really is ancient history for AI. But what's critical is that DeepSet are the original creators of the first German BERT model.
Okay, let's pause right there for a second. For someone who doesn't spend their weekends reading machine learning white papers, what exactly is a BERT model, and why does it matter that these guys built one?
So BERT stands for bidirectional encoder representations from transformers.
Oh, okay.
Yeah, it's a lot. To put it simply, before BERT, computers read text in a very linear, rigid way. They just looked at keywords. If you searched for the word bank, it didn't know if you meant a river bank or a financial bank. It just matched the letters.
Oh, I see. It had no context.
Exactly. BERT changed the game by looking at text bidirectionally. It looked at the words coming before and after a specific word to understand context and nuance.
So it could actually grasp the semantic meaning of a sentence.
Right, rather than just matching vocabulary strings. So the team behind Haystack, they've been pioneering deep semantic understanding for a very long time.
Got it. So they aren't just riding the current generative AI hype wave. They possess deep foundational expertise. And that shows in what Haystack is designed to do.
Definitely.
The documentation positions it as an architecture built specifically to merge traditional, highly accurate search mechanics with the modern generative power of large language models.
And the mechanism it uses to accomplish this is called RAG-E, Retrieval Augmented Generation.
Right, RGA. And the materials break down Haystack into 5 core building blocks that make this RAG-E foundation possible. I want to walk through these because it really helps conceptualize how this works. The first core component is simply called the pipeline.
The pipeline is exactly what it sounds like. It is the structural backbone, the routing mechanism. You can't just throw data at an LLM and hope for the best.
You need traffic control.
Exactly. The pipeline dictates the exact flow of information. It manages how a user's question travels to a database, how the answer is retrieved, and how it is eventually handed off to the language model.
Okay, so that's the pipeline. The next component is the document. Now, when I hear document, I immediately think of like a 50-page PDF or a massive Word file.
Right, but in this architecture, it's defined a bit differently. A document is an atomic unit of truth. It's a highly specific chunk of text used to answer queries.
So like just one paragraph from a dense employee handbook.
Or one specific row in a product catalog. By breaking massive files down into these atomic documents, the system can retrieve highly precise answers instead of forcing the AI to read an entire manual just to find one sentence.
Which brings us to where all those atomic units live, the third component, the in-memory document store. This is described as a secure memory storage for quick document lookup.
Speed is the absolute priority here. When an agent is holding a real-time conversation with a user, it cannot afford to wait 10 seconds while a traditional hard drive spins up to search a massive database.
That would totally ruin the illusion of a conversation.
Exactly. The in-memory document store acts like the short-term working memory of the system. It keeps those crucial documents readily accessible, so the search process happens with near zero latency.
Wow. Okay, then we have the fourth component, the prompt builder. This one seems to be where the heavy lifting happens. The deck describes it as injecting retrieved context into the LLM instructions.
We really need to underline this one because the prompt builder is the critical bridge in the entire RAG architecture. It is the point of synthesis where your raw, factual data meets the creative intelligence of the AI.
And lastly, there is a component simply called secret, which is a secure library designed to handle private info, like API keys.
Right, like your OpenAI credentials. You obviously need a secure vault so you aren't hard-coding sensitive passwords out in the open for anyone to scrape.
So those are the 5 raw materials. But the architecture really comes alive when you look at how information actually flows through them. Let's trace the execution path of a user query through this Haystack RAG process.
Okay, let's do it.
It initiates with the input. You, the user, type a question. Let's say you ask, what is our company policy on remote work expenses?
Now, crucially, that query does not go straight to the AI.
It doesn't.
No. This is the defining characteristic of RAG. The query is immediately routed to the retrieval stage. The system utilizes traditional search algorithms. The documentation specifically mentions an in-memory BM25 retriever to scan that speedy document store.
So it's like a highly efficient librarian sprinting into the archives.
Perfect analogy. It finds the specific atomic documents that contain the phrase remote work expenses and related concepts.
So the librarian grabs the specific policy paragraphs. Then we hit the construction phase. This is where that prompt builder steps in. It takes the user's original question, and it takes the factual paragraphs the librarian just found, and it basically staples them together.
Yes. It constructs a highly specific, constrained instruction set. It essentially tells the LLM, you must answer the user's question about remote work expenses. However, you are only allowed to use the factual information contained in these specific paragraphs I'm attaching.
Which then flows into the final step, the execution phase. The prompt is handed over to the LLM and OpenAI generator, for example, and the AI reads the instructions, processes the facts, and outputs a contextually accurate answer.
Written in natural conversational language. And that flow reveals the fundamental key insight from the source. Context is dynamically injected into the prompt before hitting the LLM. We are forcefully grounding the model in verified, factual reality.
Okay, I have to step in and push back on this a little bit.
Sure, what's a hang-up?
Because I'm sensing a massive contradiction here. We started this entire deep dive by celebrating the shift to probabilistic adaptable AI. We love the Mars rover analogy, right? We want an agent that is intelligent and can creatively navigate unstructured problems.
Right.
But looking at this RAG pipeline, it feels like we just slapped a massive set of training wheels back on the rover. By forcing the AI to pause, search a rigid database and strictly chain its response to those specific documents? Aren't we kind of lobotomizing it? Doesn't that limit its intelligence?
That tension you're identifying is perhaps the most important debate in enterprise AI right now. It absolutely feels like a contradiction, but it is actually a non-negotiable compromise.
Why non-negotiable?
To understand why, you have to understand the inherent nature of a large language model in its raw, unconstrained state. A raw LLM is breathtakingly creative, but it has zero allegiance to the truth.
Zero.
Zero. Its core mathematical function is simply to predict the most likely next word in a sequence based on vast patterns it learned from the internet. If you ask a raw, ungrounded LLM a highly specific question like your company's HR policy, it does not possess that knowledge.
But it won't just say, I don't know, will it?
Exactly. Because it's designed to generate text, it will confidently invent an answer. It will hallucinate a remote work policy that sounds incredibly professional, uses flawless corporate jargon, and is 100% factually incorrect.
It will write a policy that sounds exactly like a real policy, it just won't be our policy.
Precisely. In a consumer app where you are brainstorming poetry, raw creativity is great. In an enterprise environment where you are dealing with legal compliance, ungrounded creativity is a catastrophic liability.
That makes total sense.
So, by enforcing this RAG pipeline, we aren't reverting to deterministic software. The language generation remains beautifully probabilistic. The AI can still read a dense legal document and summarize it with the fluidity of a human expert.
But we are radically constraining the factual universe it's allowed to draw from.
Exactly. We are giving the off-road Mars rover a highly detailed, non-negotiable map of the terrain. Grounding the AI doesn't limit its intelligence, it focuses its intelligence on the truth.
Okay, I get it now. We get the conversational brilliance of a generative model, coupled with the factual reliability of a traditional database. It's a powerful hybrid.
Very powerful.
But, reading documents and synthesizing facts, no matter how accurately, is still fundamentally a passive exercise. To truly call a system an agent, to differentiate it from just a really smart search bar, it has to be capable of action, right? It needs to be able to affect change in the external world.
That is the crucial next step.
And that brings us into the next major section of our deep dive. Giving the AI hands through dynamic tool execution and chat agents.
This is the exact moment a chatbot crosses the threshold to become a true agent. We move from a system trapped in a text-based vacuum to a system that can manipulate external environments.
The architecture outlines a process for this called function calling. And the visual flow here is fascinating. A user request enters the system and it hits a decision node.
Right, a fork in the road.
Yeah. One path leads upward to standard LLM text generation. That's the RAG process we just discussed. The AI knows the answer. It generates text. But the other path is triggered by a specific condition. External data required.
This represents a massive leap in artificial cognition. The LLM demonstrates self-awareness regarding its own limitations.
It actually knows what it doesn't know.
Exactly. It analyzes the user's prompt and concludes, I cannot fulfill this request with my internal weights, and I cannot fulfill it by reading a static document. I need to take an action to retrieve live data.
The architecture provides a beautifully simple example to illustrate this. Asking for the weather. Let's unpack that. If you type, what is the weather like in London right now, into a true agent, the LLM immediately recognizes it does not have real-time meteorological data.
So instead of generating a conversational apology, it shifts gears. It stops writing human language, and it outputs machine code.
Specifically, it outputs a command targeting a predefined tool.
Right. The system sees that the LLM has outputted a request to execute a function named getCurrentWeather. But it doesn't just call the tool blindly. It possesses the intelligence to parse the user's natural language sentence, extract the necessary variables, and pass them into the tool's parameters.
Oh, I see. It looks at the phrase weather in London, pulls out the word London, and feeds it into the tool as the location parameter.
Exactly. Which triggers the API execution phase. The agent's backend reaches out across the internet to a live weather service API, queries London's temperature, and pulls that raw data back into the system.
Wow.
But the documentation highlights a specific feature in Haystack's experimental package that makes this all possible. It allows the LLM to pause.
I really want to linger on that word, because you mentioned earlier how significant it is. Why is the ability to pause such a breakthrough?
Well, because traditional generative AI operates like a runaway train. Once you give an LM a prompt, the mathematical engine spins up and it just starts predicting tokens, generating a continuous stream of text until it hits an end-state token.
It's just a single, uninterrupted forward motion.
Exactly. Function calling introduces the ability to halt that generative momentum midstream. The LLM essentially says, stop generating text, I need to go use a tool. The entire generative process is suspended while the system executes the API call.
And then what?
Once the external weather data is retrieved, the system wakes the LLM back up, feeds the new data into its context window, and seamlessly resumes the text generation. The LLM incorporates the live data into a natural, fluid sentence for the user.
That is a staggering level of cognitive
It
orchestration.
really is.
And keeping all of those moving parts aligned requires a very specific structure, especially if you are interacting with a user over a long conversation. The materials dive into the chat agent architecture, which maps out how this continuous loop works.
Because it isn't a straight line anymore, it's a relentless loop.
Right. The architecture relies on three main components constantly cycling data. It starts with the message collector.
The message collector is the anchor of the conversation. It uses a mechanism called a branch joiner to compile the entire history of the ongoing chat. It gathers what the user said, what the agent replied, and any tool outputs generated along the way.
So it ensures the AI always has the full context. All of that compiled history is then pushed down into the generator. This is the LLM brain itself.
Yes, the generator reviews the entire collected history and makes a decision on what to output next. But crucially, whatever the generator produces does not go directly to the user's screen.
Right. It hits a checkpoint first. The output flows into a third component called the function caller. And this function caller acts like a bouncer. It analyzes the LLM's output and asks, is this a normal sentence meant for the human, or is this a secret code meant to trigger a tool?
If the bouncer determines it is just a conversational reply, it lets the text pass through to the user and the loop ends.
But if it detects a tool command?
Then the function caller intercepts it. It executes the tool, retrieves the result, and then forces the system to loop all the way back to the beginning. The result of the tool is fed back into the message collector, and the entire cycle runs again.
The system will just keep looping internally, calling tool after tool, until the LLM finally decides it has accumulated enough data to answer the user. You know, staring at this architectural loop, it reminds me of a high-end commercial kitchen.
Oh, how so?
Think of the message collector loop like the intense dynamic between a head chef and a sous chef. The customer out in the dining room places an order. Let's say a complex tasting menu. That's the initial prompt.
Okay, I follow.
The head chef, which is our LLM generator, reviews the order and starts orchestrating the meal. But the head chef isn't fetching ingredients. The head chef yells, I need chopped onions. That is a function call.
Right.
The function caller, the loyal sous chef, intercepts that command, runs to the prep station, chops the onions, and brings them back to the pass. That completes one cycle of the loop.
But the meal isn't done.
Exactly. The head chef says, great, now I need the steak seared. Another functioning call. The sous chef runs to the grill, sears the meat, brings it back. The loop cycles again. And the customer in the dining room doesn't see any of this frantic looping and chopping in the back. They just wait a few moments, and suddenly, a perfectly composed final dish is presented to them.
That analogy perfectly encapsulates the division of labor. The LLM acts as the central executive function, while the specialized tools act as the hands.
So, we have thoroughly explored how Haystack manages RD to ground the AI, and we've seen how function calling allows it to interact with the real world. Haystack is undeniably a powerhouse. But as we transition to the next section, the materials throw a bit of a curveball.
They do.
The authors explicitly state that despite its power, Haystack is not the ultimate solution. In fact, they argue there is no single best framework.
And that is the harsh reality of the AI landscape right now. We are dealing with a fiercely fragmented ecology of development frameworks.
The architecture document actually presents a spectrum of evolution, detailing how developers are approaching this from vastly different angles. Let's trace that spectrum from left to right. On the far left, representing the most foundational approach, we have low-level graph logic.
And the defining framework here is LangGraph.
LangGraph is for architects who demand absolute, uncompromising control. It doesn't abstract anything away. It treats the AI agent's thought process as a literal graph of nodes and edges, allowing developers to manually wire exactly how logic flows.
Wow.
It is incredibly powerful, but brutally complex. It has a very steep learning curve.
Okay, moving one step to the right, we encounter versatile chaining, represented by LangChain.
LangChain gained massive popularity early on because it offered a way to string different AI components together, chaining a prompt to a model to an output parser without building from scratch.
It is highly versatile, but still requires serious engineering chops.
Then further right, we arrive at specialized NLP, which is dominated by Haystack.
Right. Haystack abandons the goal of being a generic Swiss Army knife. It is highly opinionated and built specifically to master semantic search and robust RAG pipelines.
And finally, on the far right, we have a category with a fascinating title, Out-of-the-Box Human Mimicry. The two frameworks listed here are CrewAI and AutoGen. Human mimicry is such a bold design philosophy.
It really is.
The documentation provides this dense diagnostic matrix to help make sense of all these options. It measures them against complexity, ease of use, scalability, and multi-agent collaboration. Let's translate this matrix into real-world scenarios. Who is voluntarily choosing LangGraph, which maxes out on complexity?
Picture a massive, highly regulated international bank. They want to build an AI to analyze financial histories and recommend whether to approve a multi-million-dollar commercial loan.
They can't just use a black box AI for that.
Exactly. They are legally required to audit every single step of the decision-making process. They need to know exactly which rule triggered which action. LangGraph is the only framework providing that granular node-by-node auditability. The engineering team will endure the brutal complexity because absolute control is a regulatory requirement.
Okay, total control at the cost of immense effort. Let's look at the complete opposite end. CrewAI. It has almost zero complexity. It maxes out on ease of use and multi-agent collaboration, but it scores terribly on scalability.
Now picture a scrappy digital marketing agency. They don't have hardcore back-end engineers. The creative director wants to automate social media campaigns. With CrewAI, they can essentially play a simulation game.
How so?
They spin up a digital copywriter agent, an SEO specialist agent, and an editor agent. They assign them goals, and the agents just start talking to each other, passing drafts back and forth exactly like a human team would in a Slack channel.
Wow, so it really is human mimicry.
Very easy to set up. But if that agency tried to use that same architecture to process 1 million secure financial transactions a second, it would instantly collapse. It lacks the robust backend required for enterprise-grade throughput.
It trades scalability for extreme ease of use. Next, we have AutoGen, which sits in a strange middle ground, moderate complexity, but maximum multi-agent collaboration.
AutoGen is famous for collaborative coding. Imagine a tech startup prototyping a feature. They spin up an AutoGen coder agent to write the Python script and a tester agent to run it. The tester finds a bug, explains it to the coder, and they argue back and forth, refining the code autonomously.
That's incredible. Then there is LangChain, which mirrors LangGraph's scars quite closely.
LangChain is the tool for a data science team building a generic, highly customized agent to automate various complex data analysis tasks.
And finally, Haystack. Moderate complexity, but the only framework that maxes out on scalability.
Think of a massive global law firm. Tens of millions of pages of case law. They need an AI to instantly query all that data without hallucinating. They need industrial-grade semantic search that scales across terabytes of data. They choose Haystack.
Okay, looking at this fragmented landscape, I have to channel the rising panic of a chief technology officer right now. I am a CTO. I have a limited budget. I am looking at 5 wildly different frameworks, all with steep learning curves. Aren't I just going to throw my hands up?
A lot of them do.
Why wouldn't I just wait 3 years until Microsoft or Google releases a single, unified, idiot-proof platform that does all of this out of the box?
It is the most rational reaction, and it is paralyzing boardrooms everywhere. It feels like the early days of the internet. But here's the brutal reality. Waiting is a luxury you cannot afford.
Well, why not?
Because the efficiency gains and cost savings generated by these bespoke systems right now are so massive that they are altering market dynamics. If that global law firm decides to wait 3 years for a unified platform, their competitor will adopt a Haystack pipeline today.
And they'll just outpace them.
Over 3 years, their associates will do legal research 10 times faster. Their profit margins will expand, they will undercut billing rates, and they will steal all the clients. The cost of doing nothing is actually higher than the cost of building on a fragmented framework.
So a successful CTO just needs to ruthlessly diagnose their biggest bottleneck and surgically adopt the framework designed to solve it.
Exactly. Don't wait.
Which leads us directly into the most mind-bending section of these blueprints. The documentation argues that if CTOs actually succeed in deploying these autonomous ecosystems, it will trigger an extinction-level event for the current economic model of the software industry.
This is where a technical shift mutates into a macroeconomic disruption. The slide titled, Rethinking the Business of Software, lays out a stark contrast between how money is made today and how it will be made tomorrow.
It outlines our current reality, the SaaS era. Software as a service. Pricing is tied to user seats and subscription licenses, and it highlights the foundational assumption. Humans do the labor in the software.
Think about companies like Salesforce or Adobe. They don't actually do your work. They build a digital workbench. You pay a monthly fee to let your human employees sit at that workbench.
The software is passive.
Entirely passive. It requires human keystrokes to generate value, so the vendor grows revenue by convincing you to hire more humans to sell you more seats.
But the analysis points an arrow to the agent era. The billing model is rewritten to outcome-based pricing. Companies will pay for measurable productivity, cost savings, and resolve problems, not seats.
We have to connect this back to the Mars rover. If the software is no longer a passive workbench waiting for keystrokes, if it's an autonomous agent executing tasks on its own, the core assumption of SaaS shatters. The human is no longer doing the labor, the software is the labor.
The document says, as software operates autonomously, charging for human users becomes obsolete. Think about the logistical nightmare for a traditional software vendor. Let's go back to the marketing agency. They buy a CrewAI agent, tell it to run a lead gen campaign, and the agent does it all month without human intervention. When the vendor sends the monthly invoice, what are they billing for?
Right, there's no human seat to tax.
The vendor has to shift to outcome-based pricing. They might take a percentage of the ad revenue or charge a flat fee for every qualified lead the agent generated. You are effectively hiring digital labor on a piecework basis.
It completely destroys the traditional buyer-seller relationship in tech. Procurement departments won't care about UI dashboards. They will evaluate software vendors the same way they evaluate job applicants.
Can your AI employee resolve 1,000 tickets faster than my human team?
Yes, and they will pay a bounty for every resolved ticket. In the SaaS era, vendors got paid whether you use the software effectively or not. In the agent era, the vendor only makes money if their AI actually performs the labor and delivers the outcome.
It sounds like a utopian vision for businesses looking to cut costs. You just pay for perfect outcomes, fire up the agents, and sit on a beach. But the final section of our blueprints throws a massive bucket of ice water on that fantasy. We have to confront the agent risk radar.
It is a vital reality check.
Because unleashing probabilistic, autonomous intelligence inside a corporate network introduces existential threat vectors. The architecture visualizes these threats as a triangle of risk. The top point is enterprise security, privacy, and compliance risks.
This brings us back to function calling. It's harmless to let an AI call a weather API. It is an entirely different universe of risk to give an autonomous agent direct access to your company's secure internal HR database.
Or proprietary financial records.
Right. If an agent misinterprets a prompt or is hit by a malicious prompt injection attack, could it autonomously decide the most efficient way to answer a question is to accidentally email the executive payroll spreadsheet to a junior marketing team?
Oh my God, that is terrifying.
The security perimeters of the internet were designed to keep malicious humans out. They were not designed to monitor an unpredictable, high-speed AI operating inside the network. Rebuilding those perimeters is a massive undertaking.
Okay, the bottom right point of the triangle is model hallucinations, the inherent weakness of transformer models generating false information.
Even with robust RAG pipelines, the core engine is a probabilistic text generator guessing the next word. There is always a risk it will confidently stitch together a totally fabricated fiction. If an agent negotiates a contract and hallucinates a legal precedent, the fallout could be catastrophic. Eradicating hallucinations entirely is mathematically impossible right now.
Which sets up the final point on the bottom left, stochastic testing. The complete breakdown of traditional software QA when outputs are no longer strictly predictable. The authors dedicate a whole section to the stochastic testing dilemma.
For developers, this is the most critical hurdle. The architecture visually contrasts the two testing paradigms. On top, deterministic unit testing.
The visual is a single straight line moving cleanly from left to right. It says you can run a unit test to ensure that 2 + 2 always equals 4.
That is the bedrock of software engineering. You write a test that says, if I input X, return Y, it's binary. The software is either broken or it's not.
But the bottom half, stochastic AI testing, is pure chaos. It starts as a single point, but shatters into a messy spray of countless thin lines radiating in every direction. It looks like a frayed rope exploding. The text states, agent outputs are probabilistic. Traditional unit tests fail. Okay, I am adopting that CTO panic again.
I don't blame you.
If 2 + 2 doesn't always equal 4 in this new paradigm, why would any sane enterprise trust an AI agent? Are developers just crossing their fingers and hoping for the best?
It induces vertigo for the industry, but developers aren't just crossing their fingers. The architecture states they must rely on new tool sets for pairwise comparisons and regression tracking over time. You have to stop checking for exact mathematical matches and start checking for boundaries of acceptable logic.
How does that work in practice?
Let's say you build an agent to summarize an hour-long meeting transcript. Because it's probabilistic, if you ask it to summarize the same transcript 10 times, it will generate 10 slightly different summaries. A traditional unit test looking for a specific string of text will fail every single time. It will tell you the software is broken, even if the summary is brilliant.
So how do you prove it works?
Pairwise comparisons. You have the agent generate summary A and summary B. Then you bring in a separate evaluator AI to compare both against the original transcript. Did both summaries capture the main action items? Yes. Did they invent a decision that wasn't made? No. Therefore, both summaries are successful outcomes. You are testing the competence of the thought process, not the exact wording.
I see. And then you run regression tracking to monitor the boundaries of that messy spray of lines. If the logical accuracy drops after an update, you've detected a regression. We have to master the art of managing probability.
Exactly. It's a profound operating philosophy.
It really is the perfect synthesis of everything we've unpacked today. From the paradigm shift away from deterministic tracks to the adaptable rovers of AI workflows, we've seen how Haystack uses RA to ground models in reality, and how dynamic function calling turns them into active agents interacting with the world.
We navigated the fragmented ecology of frameworks, matching tools like LangGraph and CrewAI to specific enterprise needs.
And we confronted the massive threat to the SaaS business model, moving toward outcome-based pricing and digital labor while balancing the terrifying realities of enterprise security and stochastic testing. All of this culminates in the final slide. AI agents are not just a feature. They are the foundational architecture for the next era of enterprise software.
The infrastructure of the future is being laid down right now, whether legacy systems are ready for it or not.
So whether you are a developer choosing a framework or a business leader prepping for outcome-based pricing, this structural shift dictates your future. The era of the digital assembly line is ending, and I want to leave you with one final provocative thought.
Let's hear it.
If major software companies are inevitably going to stop charging subscriptions for human seats and start charging for the actual labor their AI agents perform, how long until these software vendors stop seeing themselves as technology companies and are forced to legally classify themselves as massive digital employment agencies?
Wow.
If an autonomous AI flawlessly performs the job of a senior accountant, is the tech provider actually just the world's largest automated accounting firm? This tech completely blurs the line between the toolmaker and the worker. It fundamentally redefines what a company even is. It is something to think deeply about the next time you log into a SaaS platform and pay for a seat. Thank you for exploring these massive architectural shifts with us on this deep dive. We will catch you next time.